NVVA, Nevada Virtual Academy Proficiency Exam Problem. Translate this problem to an equation and solve. Find two consecutive integers that have a product of 182. Okay? And we did solve a similar problem, I believe yesterday. When you talk about consecutive, hold on, consecutive integers, right? Well, consecutive are one after the other, right? Basically, when you say the consecutive integer, you will say the next one. 1, 2, 3, 4, and so on, right? To positive infinity. What you notice, to get the next one, you're adding 1. To get from 2 to 3, you add 1. You add 1. So if one of them, let's name my first integer k, okay? Well, the next one will be k plus 1, all right? These are my two consecutive integers, all right? So I got my consecutive integers. They have, we know more stuff, more information is given about them, and the information says they have a product of 182. Product means multiplication, right? So k times k plus 1 equals 182. Well, let's do this multiplication. K times k is going to be k squared plus k times 1 will be k, that equals 182. Okay? To solve it, you need to move everything on the left side, and I will subtract 182 from both. Same principle you're applying to every equation, right? Whatever you do to the left, you're doing to the right. Your equation now will be k squared plus k minus 182 equals 0. And you have to solve it. What are the rules? Looking for common factors here. There is none. I'm checking to see if this is a perfect square, and it is not, because the last number is also negative, and you guys know this is not a perfect square. We're not getting into those details here. Another way, another step, the next step should be to try to factorize this, right? To factor it. If this is not prime, and we kind of guess that it's not, because we need to put the two answers in here. No option is given as, you know, no integers possible, right? The first number in each one of your binomials, if this will be your factors of your trinomial here, will be k. Now, because the last number is negative, I will have a positive, I will have plus, and I will have minus in my parentheses. And next I'm looking for factors of 182 that will add up to what? They will add to 1, okay? Because your middle term here is positive 1, which tells you that whatever you will have in k plus parentheses, that number in absolute value will be greater than the other one with the negative sign, with the minus, k minus whatever number, okay? How should you start? Well, first of all, I recommend you to try a prime factorization of your 182. And as you notice here, the first prime factor will be 2. 2 goes in 18 9 times, right? 2 goes in 2 1 time. Okay, what should be the next step? Well, the next step here would be to see if 91 is a prime number or not. Most likely is not, okay? And you guys may not see this, but this is divisible by 7, okay? You should try a few, times. And 7 goes in 9 how many times? 1 time. 7 times 1 is 7. Out of 9 would be 2. 7 goes in 21 3 times, right? So I have 13 as the next prime factor. So basically here, your number can be written as 2 times 7 times 13, but you need only 2 factors in here. So looking for factors of 182 or negative 182, the best option would be what? 14 times negative 13. And I know for me it was fast. For you guys, trial and error, and that may be one approach. Okay. Well, 14 plus negative 13 is 1. Positive 1, positive k is your middle term. We're good. This is it. So it'll be k plus 14 k minus 13, and this should equal 0. Now, for this product to be 0, each one of these binomials has to be 0, which gives you your two roots. From the first one, k plus 14 equals 0, I have k1 equals negative 14, okay? And the other one, k2, will be 13, okay? And these are your two possibilities. Now, there is nothing in this problem saying that your integers are positive or negative, right? So if I will start with k1, negative 14, well, if the first one is negative 14, the next one is going to be negative 13. And you should check, is their product going to be positive 182? Yes, it is. Okay, so you have one possibility in here, negative 14, negative 13. Then you go with the other one. If k equals 13, then I have 13 and 14. All right, so it seems to me that you have to write your answer in here as two pairs, right? You will have either 13 and 14, or you may have negative 14 and negative 13. Both these pairs of consecutive integers will satisfy the requirement in here that their product is 182, besides the fact that they are consecutive integers. Okay, tricky question. There are, like I said, two possibilities, two solutions in here. I hope you guys understand, but let's actually try something else. Like I've said, for me, you know, I'm the math teacher and I can see certain things and correlations, patterns faster than you. Eventually, if this way, this approach of factorizing and of factoring your trinomial doesn't work, okay, you may try, and this may be the most secure approach, to go with the quadratic formula, right? Remember, quadratic formula says that your roots x1 or 2 will be negative b plus minus square root of b squared minus 4ac, which by the way is your discriminant, your delta, right, over 2a. So if everything fails, then you should try this. What is your a? Well, a to this equation, for this equation here, is obviously 1. Your b is your first degree term coefficient, right, which is also 1. And c, which is your free term, the term with no k, with no variable on it, which is negative 182. The first thing when you use quadratic formula is to find your discriminant, which is your b squared minus 4ac. Why am I doing that? Well, because if that's negative, you have no real roots. It has to be 0 or positive. Let's find out. B squared, 1 squared will be 1, minus 4 times a. 4 times 1 times what? Times negative 182. This equals what? 1 minus minus, negative negative, will make a plus in here, right? And I have 4 times 182. 4 times 2 is 8. 4 times 8 is 32. 4 times 1 is 4, plus 3 will be 7, right? So your delta is 1 plus 728, which gives you 729. And I bet that this one is a perfect square. Okay? Perfect square. And you know, because you don't have a calculator, you may think about, you know, what you may try to approximate. What is square root of 729? We will need this in your quadratic formula, right? And you know, obviously, or you know, not so obviously, you may try different numbers in here. Now, if you think about 700 or 800 or 900, right? 900 is actually 30 square, all right? which means this 729 is definitely less than my 30, okay? But I'm looking for a number that squared ends up with 9, all right? And for less than 30, let's say between 30 and 20, I have 27 and I have 23. Do you guys understand why? Because 3 times 3 is 9. 7 times 7 is also, I mean, is not 9, it's 49, but ends with 9. So these are my two possibilities. And if not, it definitely should be less than 20, which is not the case because we know 17 squared is 289. So 17 is not. Should be between 27 and 23. Okay? I know it's not 23 because 25 squared is 625. 23 is less than that. So definitely not the case. 27, if you don't believe me, you should go ahead and let's do it together. 27 times 27 is what? 7 times 7 is 49. 7 times 2 is 14, plus 4, 18. 2 times 7 is 4. 2 times 2 is 2, plus 1, 5. Let's add them up. 9, 2, and 7. 729, we got it right. Square root of that is 27. Okay? Now going back to your quadratic formula here, you will find that your two roots, and I'm going to erase everything on the left side here. So I have my x1, 2 as being equal to what? Negative b minus 1 plus minus square root of delta, which is square root of 729. We can write it here as plus minus 27, right? Over 2 times a over 2. And this gives you the two roots. Minus 1 minus 27 is negative 28. Divided by 2 is negative 14. Okay? The other one, negative 1 plus 27 is negative 26, right? Over 2 is going to be negative 13. Okay? And these are my roots. Hold on. This is positive 26, right? So it's positive 13. I was just worried that why are we getting the same sign? So negative 14 and 13, which we previously got in the other, using the other method. These are your two possibilities for k, not x, right? We're talking about k for the given problem, k. And then you should try again, consecutive, negative 14, negative 13. You go with the positive ones, 13 and 14, and you are done. Okay, so this is just another way in which you can solve it. If you have no clue what would be the factors of your quadratic equation, the quadratic formula, the most secure one, will definitely tell you what the roots are. Okay, well, this is it. Thank you.